All right, so we're going to continue with our angle addition laws and solving, and just go over more types of how they can look and how we might approach them before we move on to our next set of theorems dealing with double angle. So again, just a reminder, our three postulates or rules for sine addition, or angle addition I should say, is sine of A plus B, if it's plus or minus, we would have sine A cosine B plus or minus cosine A times sine of B. Then for cosine, if it was A plus or minus B, it would be cosine A cosine B minus or plus, because when we have addition on a cosine, it's subtraction in the rule, sine A sine B. And then lastly, we have our tangent of A plus or minus B equals tangent A plus or minus tangent B over 1 minus plus tangent of A times tangent of B. So these were our 6 angle addition. And so what we're going to look at today is solving. And we're solving on the interval from 0 to 360. And we're going to go through 3 examples here, just to kind of refresh our memories, as well as to look at some different methods that we might end up having to use. So this first one that I want to go through with you is sine 2x cosine x plus sine x cosine 2x equals -1. So when I look at this, knowing that we're using angle addition at the moment, I'm going to be trying to see, do I see any one of these things? Now, before break, we looked at some that went backwards. So we looked for this side so that we can simplify it down to one trig function. And so when I look at this, I have sine of 2x cosine x over, and then I have a sine x, so this, the other trig function, and cosine 2x. So when I look at this, I go, that looks really similar to the sine of A plus B, where 2x would be my A, x would be my B, and then cosine A, I have that, and cosine B, I have that. And so using the plus sign, I know that I can change this whole expression here to sine A plus B. So now I have something that's condensed into a much simpler looking version. So when I actually add these together, I end up with sine 3x equals -1. And we look, now we're going to look at which angles give us a sine value of -1. And we want to remember that because of the 3 here, we have to think of it as 270 and then the other 2 coterminal. So I should have 3 angles here. So when I add 360 to 270, I end up with 630. And then when I add another 360, I end up with 990. To solve for x, we divide each by 3. So I have x is equal to 90, 210, and 330. So those would be the 3 angles that if we plugged them into that equation would work to give us -1. Our second example, this up a bit. We're still solving from 0 to 360. The only difference here is this one's going to have fractions in it. and it has some inverse functions thrown in. So this one here has a lot going on. So when I look at this, I go, okay, I know I can change these to sine and cosine to help me get all sine and cosines. So let's start with that. So I'm just going to copy this down. Cosine 2x, sine x, sine 2x, cosine x, and then secant comes to the bottom as a cosine x, and cosecant can come to the bottom as a sine x. So from here I go, okay, now I have my fractions, everything sine and cosine. Because it's an equation, I can multiply everything by my common denominator to cancel it out. So my common denominator is going to be 2 sine x cosine x. So if I multiply everything by 2 sine x cosine x, I'm going to be able to get my denominator to cancel out. So here the sine x's will cancel, leaving me with 2 cosine 2x cosine x. On the second one, the cosines cancel, leaving 2 sine 2x cosine x. Oops, nope, sine. Wrong one. Sine x. And then over here, the whole thing will cancel, leaving me just equal to 1. Alright, so from here, I go and look to see, can I condense this further? Again, angle addition laws are in the back of my head because that's what we're trying to look at right now and practice using. I notice that I have cosine, cosine, and then sine, sine of the same angles. So I have a cosine 2x, a sine 2x, a cosine x, a sine x. What's throwing me are these 2's in front. So what if I factor out the 2 that's in front, and I look just at what's left? And I want to see, does it match one of my angle addition? And when I look at it, I go, yeah, it matches my cosine. And then I look at this, and it's going to actually end up being subtraction. Because remember, the cosine rule is the opposite sign. So I can write this as 2 cosine of 2x minus x. Well, 2x minus x, I can combine that to just be cosine x. Divide the 2 over, so I have cosine x equals 1/2, and now I look to see what angles, when I take the cosine of it, gives me 1/2, and we get 60 degrees and 300 degrees. Okay, so that one had a lot going on. So when we started it, it had both fractions and inverse functions. So I started by taking the inverse and making them into sine and cosines. And after doing that, I noticed that I could do a common denominator for all of my fractions, multiply each term by that common denominator so that I could cancel out the fraction part. When I looked at what's left, I noticed I had a potential for a cosine addition, or sorry, cosine subtraction, but these 2's were in the way. So because they both had it, I could factor out a 2, leaving me with my cosine subtraction. So when I look at my a and b, I can do cosine a minus b, and that got me to cosine x, 2 times cosine x, divide the 2 over, got me here to where I could then think what angles give me a cosine value of 1/2. Okay, the last one that I wanted to do with you guys, you're going to need some space for this one. So if you're running out of room at the bottom of a paper, I would suggest going to a new one, because this one's going to take up some room. And what's going to make this one take up room is that there's an ABC to it. And we're going to do another one like this in class, so that way if there's any questions or confusion on any part, you can ask. So this next one we are going to be answering some questions in regards to sine of a plus b. But the difference here is how we're given the information. So sometimes we're going to be given information like this. So I'm going to be told what the sine of A is and told what the cosine of B is, and I'm told that neither of them are in quadrant 4. So what these are leading you to have to do is draw out the triangle. And now there's nothing saying that these are going to be on the same grid or even in the same triangle. So I'm going to draw these in two separate grids. So it says right here that neither of them are in quadrant 4. So I'm going to cross off quadrant 4 because I know that's not where they are. Now if sine is negative, so sine of A is negative, well that tells me it either have to be in 3 or 4, but if it can't be in 4, then I have to draw it over here. So here's my angle A. My sine, opposite over hypotenuse, and then I can use Pythagorean theorem to get negative 12 for my adjacent. When it comes to cosine, so cosine here is positive. So if cosine's positive, that means it would have to be in 1 or 4, but it can't be in 4, so that means I know I have to draw my B up here in quadrant 1. Cosine is adjacent, so adjacent 3 over hypotenuse 5, Pythagorean theorem, we get the height is 4. So when you're given your information like this, you have to sketch out your own triangle using the All Students Take Calculus to help you with what quadrant your angle is in. Now over here, it's really common to forget that it's supposed to be a negative 12 and we'll put positive. But you want to also consider if we're in quadrant 3, that means both x and y have to be negative. Otherwise, if it was positive, it would be A over in quadrant 4. So one of the questions you're going to be asked after you get this all drawn out is it's going to ask you what is sine of A plus B. And this is where we're going to actually use the values from our triangle, the fractions from our triangle. So sine of A, we were told was negative 5 over 13 times cosine of B. So cosine of B, so I'm using my sine A cosine B plus, cosine A sine B. So I'm using my angle addition here. So I have negative 5 over 13 times 3 over 5 plus cosine of A. So I'm going to come back over to A and think, what's my cosine? So it's my adjacent, negative 12 over my hypotenuse. And then sine of B, so come over to B, opposite over hypotenuse, I'll have 4 over 5. So from here, I can actually multiply. So I'll get negative 15 over 65, and I'm purposely not going to reduce until the end here. Because when I multiply across here, I'm going to get negative 48 over 65. And so the reason I don't want to reduce is because leaving it as 65, I already have a common denominator. So from here, I can go ahead and add these together, and I get negative 63 over 65. And that would be my final answer in fraction form. The second part to this same question, in what quadrant is the terminating ray of A plus B? So in what quadrant is the terminating side of A plus B? So this is where we have to think about our sine and our cosine of a plus b. And we're also going to consider our all students take calculus. So when we try to figure out where does a plus b fall, I'm going to start by looking at, is my sine of a plus b positive or negative? So when I look up here, my sine of a is negative. My sine of b, 4 over 5, is also going to get, when I add them together, is going to give me a negative. So when I did my sine of a plus b, I got a negative. So right there, I know that my sine of a plus b, because I did it right up here already, I got a negative number. So right away, that means my quadrant is gonna have to be, or it can't be in quadrant 1, because all of them are positive, and my sine has to be negative, so that means it also cannot be there. Cosine. Is cosine of a plus b positive or negative? So now we have to go and do our cosine addition to figure out, are we going to be positive to be in quadrant 4 or negative to be in quadrant 3? So if we do cosine of a, so a, our cosine is negative 12 over 13 times cosine of b, which is 3/5, minus, because we have to go opposite. Now we're going to do sine of a and sine of b. So sine of a is negative 5 over 13. Sine of b is 4 over 5. So when I multiply, I get negative 36 over 65. And over here I end up with double negative, so it turns it into a plus 20 over 65, which gives me negative 16 over 65, which means I have a negative. So if my cosines of the sum is negative, it can't be there, meaning your final answer is that your sum is in quadrant 3. So we're going to do another one of these in class, just because there is a little bit, oh, you couldn't even see what I was doing. I'm sorry. Okay, so again, after we found our sine of a plus b, when you're asked to find which quadrant the sum is in, you find the sine of a plus b and determine if it's positive or negative. Well, we did that in part A, so I didn't redo the work for it. Because it was negative, I know it can't be in these two quadrants. So then I have to figure out what is cosine of a plus b. Is it positive or negative? Because that'll help me eliminate one of these two remaining. So using the same pictures up here, use the addition rule, or in this case subtraction, to plug in the values and decide, or figure out, do you get a negative or a positive? Because I got a negative, it meant I couldn't be in quadrant 4, so I have to be in quadrant 3. Okay, so what we're going to be looking at tomorrow is another one just like number 3 here, and then going over any questions. And this is actually our last day, going to be our last day tomorrow on angle addition, before we move on to the next set of identities, which are double angle.